Okay, I think it's recording now. Okay, everybody, my name is Devan Varu and this is my Wheel of Fortune, the object-oriented version. So let's go over through the data member first. So this one is a boolean winner false. These are just a few hint. This is a character that is input. We'll go over through it later. String phrase, random phrase, string hidden string builder, which is a hidden phrase, string of list, and hash set of character. Okay, let's go over through the random phrase because that's the first function, right? So what this random phrase does is it gets a random phrase from the phrase file and it returns a phrase into a string. So this phrase is a random phrase that we got from this phrase file. And generate hidden phrase, that phrase. So this one, the random phrase that we got, we're gonna put it as a parameter for the generate hidden phrase. So what is generate hidden phrase gonna do? Let's go over to generate hidden phrase. So it's gonna take a string, it's gonna create a hidden phrase, and it's gonna create a string builder, and it's gonna take that string in, and this is it's gonna loop through over it, and if the character is not if the character is not space, then it's converting the character into a star. If it's space, it does do anything because we still need space in the hidden phrase, right? So yeah, only if it's not a space, then we convert it into a star. What do we do next? Phrase list. We'll go over through phrase list later. Oh, we actually did. So yeah, the phrase list is going to be a list of phrase, and we're going to return it as a string in the phrase. And let's see, hash set character list of guests. So this one is going to be a list of guests. We'll go through it later when we actually use it in the program. So let's go through the main Wheel of Fortune object, constructor, reference, and it's going to call one method, right? Process game. So everything is happening in the process game. Let's go over process game. Let's see what it does. Where's the guy? So the guy first has an intro method. Let's go through introduction right here. So this one's just gonna do all the system that print everything, la la la. Let the user know about the rules. So it's gonna take the hidden phrase right here. User try, the number of try the user gets, which is 7, and it's gonna tell the user, okay, here's the hidden phrase and here's the try. Best of luck. You may start now. Okay, that what intro does, and let's see what does it do. It's a loop. It's a loop from here to here. Is a winner and user try. So remember, winner was false. So if winner is false, inverse of that is true. So this condition is true, and user try 7 is definitely greater than 0, right? So this one is true, and input gets get guess. What is get guess? Let's see, get guess. Get guess is just a scanner that takes the user input. So we do the scanner, that next, that we then convert it to lowercase, and then we get the character at 0. So if the user types in like a huge string, we just get the first letter. So yeah, we only need the character, right? So we're returning a character type, and we have here lowercase. So we're converting whatever if the user does a capital, or we're just gonna convert it to lowercase. And I'm converting lowercase as well in random phrase. So yeah, it gets the random phrase and it converts it to lowercase. So everything is lowercase now, so we don't have to worry about case sensitivity anymore. Okay, what do we do next? Let's see, process guess. Process guess should be right here. This guy. So what does this guy do? Huh? Valid guess, correct guess. Okay, what do these do? Let's see, valid guess. So it's gonna take the input, which is from the user, and it's gonna make sure that the user input is greater than A and less than Z. So it's valid, right? Because that's alphabet at the end of the day. Whatever the user selects between these two, it's gonna be a valid guess. And what's the next one? Correct guess, correct guess, correct guess. Phrase that index our input. Okay, so we're gonna get the user input, and we're gonna check it on the original phrase. So let's say if the word in phrase, there's a word that has B, and the user inputs E. So the E is gonna have an index of some kind, right? In my example that I just gave it, the index is going to be 1, and 1 is not equal to -1, right? Because it exists. So if it exists, it's correct in the phrase, and if it's not, it's going to return -1. So This one just makes sure that the guess is correct. And new guess, what the new guess does is list of guess contain input. So the user input, does the user input contain list of guess? Right now it doesn't, right? Because we didn't add any kind of input or anything in the list of guess, so of course it's not going to have it, right? So this one is going to be true for a new character. Okay, we got through those methods. Now let's go through what happens in this if condition. So if all of these are true, so we remember the hash set that we had. So we add the user input in it. So now it's added as a is in the hash set. So the user knows that okay, it's added now, so it won't get the same prompt again. But we don't want to do the same thing again for. We don't want this code to run again, right? If it's the same input, it's just a waste of time, right? So we don't give them the same input, we give them a different, but I'll go over that just in a second. So what does this one do? For int I is equal to 0, I less than hidden phrase, and it goes through the hidden phrase, and it goes to the phrase character I input. So it's if the character at the hidden phrase. So what this one does is just gets all the character and converts them into char, so in converting to the character the user input. So it's gonna go through the whole phrase, gonna look through all of the repeating character e a, like those characters get repeated most in our phrase.txt, and it's gonna set them. So it's gonna take that character and replace the hash with the character. And we do, why do we do loop, right? It's just, why should we do it when we can do it single line, right? But for if there's more than one repeating word, then we need to go through all the whole phrase. So that's why we're going through the whole phrase in this condition right here. Okay, I think I over explained that one, but it's okay. So this one, what is it? It's a valid guess, it's a correct guess, but it's not a new one. So what do? We don't penalize the user, right? Because they already guessed it once, right? So we do, okay, that is correct, but you already guessed it, and we don't do anything, right? Now what if it's valid, it's not correct, but it's a new guess? It's new and it's valid, but it's not correct, right? So it's an incorrect guess. But it's, yeah, so we say nice try, unfortunately not for this phrase. Then we add that character in the hash set, and we decrease the user try and we increase miss by 1. So the user have now one less chance of guessing the phrase, and it increases the miss by 1. So why do we do this one? List of guess that add input, right? Why should we do it? So we do this so the user is informed that okay, you already guessed this one, and we don't penalize him twice for the same wrong input. So that's what we do here, right? It's a valid guess, it's an incorrect guess, and it's not a new one, but we don't penalize it because they already guessed it wrong once in here. So we just send them, notify them that hey, you already guessed it once, are you trying to lose? And this last one is for if there's not alphabet. Okay, and user guess plus plus. So we just increase this every time the user guess right, wrong, valid, invalid, whatever the user guess, this one's gonna get increased. Okay, and this one was process guess. So process guess. Okay, I'm done with this one. Now when the user playing the game, at some time the phrase is going to be equal to the hidden phrase, right? Sometime, like after playing for a while. So that's what we check right here. If the hidden phrase is equal to the phrase, then it's a winner. And what we do here, we get the hidden phrase and we convert it into a string. And then we say some apart, congratulations, you have won the game, la la la, user guess. It throws in how many guesses the user took. And we set the winner is equal to true. So once we set the winner is equal to true, this whole condition is going to be false, right? So the player exits the program, and that's how they win. And but what if they auto tries, right? Because it's also an condition, right? So if this one is false, then the whole thing's going to be false as well. So we decrease the user try every time the user incorrects a guess. So else if user try equals 0. So if it's equal to 0, we do system.out.print out and out try. So we do this, and then this is false. So the user is kicked out of the game. Kicked out of the game is not a proper word, but they exit the program. And what if we do, if they're not the winner, they're not the loser, but they're still playing the game, right? So we let them know, hey, user, These are your number of tries. These are the number of misses that you made. This is your previous guess that's gonna throw out the hash set, and this is the current hidden phrase. Okay, I think I went over through everything. Let me double check. Where is main? Yeah, I think I went through everything. So let's go through a test case. The first test case was O. That is correct. So it's gonna give us correct prompt, not gonna penalize us, and add it to the hash set. So let's do repeated correct guess, right? Because we already guessed O previously. Let's do that. That is correct, but you already guessed it a minute ago. Our concept seemed to be nervous today. So we don't penalize the user, but we let them know, hey, you already guessed this once. No penalty, nothing, no revealing in the hidden phrase because they already guessed it once. Now let's do an incorrect one. I think, yeah, we don't have Z in this one. Nice try, unfortunately, not for this phrase. La 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 la. We don't do anything. Our number of tries is decreased by 1, so now the user only have 6 chances, but they missed one time because they did a miss, right? And we added to the previous guess. So if the user again purposely tries to use this one, it's gonna say you already guessed this one once wrong already. Are you trying to lose purposely? We don't change the hidden phrase. The number of tries same and number of misses are same. Why? Because the user already guessed it. It doesn't make sense because they guessed it. Why should they penalize for a wrong answer again? Okay, now I think I went over all of them. Now I'm gonna do the winner, then I'm gonna do the loser. So let's do the winner. Look at that, I know the whole phrase. Change you wish to see. Okay, so I guessed it correctly, and it's gonna be that is correct. This one is still the correct guess phrase, and from here is congratulations, you have won the game in 19 guess, right? And it's exit out. Okay, that was the winner. Now let's do the loser, my favorite one. Okay, let purpose losing is hard. Let's throw an X and Y. I know we don't have those, or we do. Let's do, which letters would I do? Okay, I finally lost. Okay, so yeah, this is still the incorrect guess prompt, and this one is the loser prompt, out of luck and try. So yeah, that's it for the Wheel of Fortune object. Now let's go through the bot, my favorite bot. Let's go. Let me make this smaller so it's more readable. So this one is same from the previous Wheel of Fortune object. Everything is same up until here. So this one is a array of character, right? Which we're going to use later, and this one is a map that has a character as key and a value of double, and it named my map, and we'll go over it later. Okay, so for now these two are the new things, so we need to be careful where are we going to use it. So la la la, we go to the main Wheel of Fortune bar, Wheel of Fortune bar, we do the process bar and process game. Let me go through process game because it's same as the Wheel of Fortune object, but there's just one thing that's different. So let's go through that so it's easier to understand. Random phrase, intro is the same, general hidden phrase, all these three guys are the same. Process guess is the same. Process game. In the previous one we had input is equal to get guess, right? Which was a scanner from the user. But for this one we need to make a bot that is smart. I think it's smart, but yeah, it should be smart, right? So that's what we're trying to do. So with this one I'm feeding him I'm giving him a method, high prop guess. So what is high prop guess? We'll go through that later. But for now, this is the only change in the process game that is different from the object-oriented version of Wheel of Fortune. Okay, now let's do process bar. What does process bar do? Let's go through it. Where do we have the bar? Oh, right here. So process bar has get all phrase, initialize my map, and high prop guess. Let's go through the first one. So what does this one do? This one, my category, file read string, get phrase, lowercase, repeatedness, character. Damn, we're doing a lot of things, huh? Let's go through it one by one, huh? So this one, files.read string with ring, the phrase.txt. We're reading it. We replace it to lowercase, right? So everything is lowercase in here. We replace all empty space with no space. So we're removing the space between each phrase. and we convert it to a character array. Okay, and we converting it into an array of character. I went through a lot quick. Let me go through slower. So this one is my cat array. Do you remember our data member? Where is it? So that's an array of character, right? So it's a if that's a array of character, this should be a character of array as well, right? So that's what I'm trying to do. I'm trying to get all the phrases from this file. I'm lowercasing them. I'm replacing all empty spaces with no space, and then I'm converting it into an array of character. So this my cat array is just an array of all the characters that are present in this phrase with no space and no capital letter, all small letter. So that's what this line does. Okay, we went through with that one. Now let's go initialize my map. Let's see what does this one do. Let's see. It does for loop. It does have two for loop. Int I97, I112, 1 plus plus my map. So I think I should go over to this one. So in my map, if in a map, if you want to put something, it's like the syntax is my map dot put dot key dot my map dot put and key and the value. So okay, from that we can understand. Okay, the key is gonna be char dot character dot I, and the value is gonna be 0.0. Okay, so we established that. Now what I'm doing with my map is I'm making a map of all the character from A to Z, and I'm giving them 0.0, right? Why am I doing that? The way I'm functioning this bar is I'm gonna feed him all the phrases from here, I'm gonna feed the whole sentence to it, and then I'm gonna increase the probability as the character appears. So let's say character A appears, so that one's gonna increase. We're gonna increase his chances compared to Z, which never appears in any of those phrases. So that's what I'm trying to do in my bot, right? So this one is like we're putting those right now in this loop. We're just putting those characters just A to Z inside the map. That's all we're doing with 0.0. No chance here. No, none of them have any chance. It's just we're putting them in the map. And we're starting from 97 to 112. 97 because the ASCII value of small a is 97 and the Z is 112. So we're putting all the alphabet. And yeah, I did this rather than doing like I plus 97 because I just felt like there was better way of doing it, so I did like this. Yeah, let's go through the second loop. A lot of things are going on. Let's see. My map put. Okay, we remember my map dot put. This one is the key, and this one is the value. So we know this one is a value, so it's got to be double, right? Because our map has double here. Our map has double, so that's going to be double, right? But what are we doing here? We're casting it to double, so this one is not double, right? If we're casting it to double, this one should not be double. Otherwise, why would we cast a double as a double, right? So this one is not going to be double. So what is this one going to be then? Let's see. My map that get that this. So I think if I go through an example, it'll be easier. Let's say the first time A appears. What's the chance of A, right? From here we can say it's 0. So it's gonna do 0 plus 100 divided by my char array. So let's say my char array length was 20 and A appeared once. So what's the chance of A? 1 in 20, right? So that's what we're doing here. We're getting the previous chance and we're adding it to the new chance. So the new chance is just the number of length 100 divided by the number of length. So the longer the length, the smaller the chance is going to be of that number appearing, right? If the phrase list is 100 and A appears only 1, then the chances are going to be 1 in 100 as compared to 1 in 20 if the phrase length is 20. So that's what we're doing, right? 0 plus this chance. And let's say A appears again, right? So here last time it was 0, but now A has some value, right? We're gonna get that A value, which is like, I don't know what's the percentage, but for the example, let's say 2. So it's gonna be 2 plus 2 4. So A value is increasing the more it appears on the phrase. And by doing this, like the character which gets selected more gonna have higher probability compared to the character that gets selected less, like Z. Okay, so I explained this one, but what are we doing with the 1000 and divide 1000 math around, right? So we get this value, but we're using double, right? So it's gonna be like a lot of decimal point. But for our example, we don't need that kind of accuracy. We just need like 2-digit max. So what I'm doing is I'm multiplying this by 1,000. I'm doing the math round. The math round is an interesting function. It rounds the number and it rounds a function. So it removes the decimal points, and then we divide it by 1,000. So I think if I go through example math, it will be, so let's say we have 3.14, right? Pi value. So we multiply it by 1,000. So 3.14 is gonna go through. It's gonna have a lot of decimal, right? Then we round that character, so it's gonna be like 3,140 something something, and that's rounded, right? So now once it's rounded, we're gonna divide it by 1,000, so it's again gonna be 3.14, but without the additional decimal value. So it's just sorting the decimal value, the decimal length, not like we don't need the extra character. So that's what we're doing here. I over explained that one way too much. Let's go through the last one, high prop guess. So remember high prop guess, the one that we use as an input for our process game instead of get guess. So this is where our actually the bot brain is going on, you could say. So what do we do here? We get a random phrase. Okay, we do random person random dot next dot double into 100. So what does next double do? Next double gets a random number from 0 to 1, right? So let's say we got 0.87. 0.87 times 100, that's 87, right? So we got 87 percentage. For the one that I'm explaining right now, let's give it 87. Current percentage is 0, random character is empty. Okay, I think if I go through example, these are easier to explain. Now we get the map and we go through each of the value of map, right? We're doing it for each for a map. So for each value here we define the type. Here we use a variable, and here it's from which data structure you want to loop through. So for a hash map, we define it like that: hash map dot entry dot set. And this is the way of defining, like if we're going through character is character, if we're going to the entry is entry. So this is how we define for map and this is the the variable that's gonna we're gonna use in the map in our example. So let me go through again. It's a syntax for going through for each value of a hash map, and this is the value that we actually use. This one is going to be our ABCD and all this key and all the value. Okay, I went over through like this one: current percentage entry dot get value, random percentage current value, random character entry dot key value. A lot of things are happening. Let's take an example. Let's say I got 87 from random person, right? 0.87 into 187. Current percentage 0 and entry dot get value. The first loop is going to be a, right? Let's say a has a chance of 5, so it's going to go current percentage equal 0, right now. So current percentage equal 0 plus 5, so its current percentage is going to be 5. Is 5 greater than 87? No, not yet. So we skip through it and we go through b has a value of 6. So current percentage equals current percentage plus entry get value. So 5 plus 6, so that's 11. So is 11 greater than 87? No. So we go through C, D, E, F, G, H, I, J, K, all of them until let's say we get to T. So current percentage, when we get to T, let's assume current percentage was 82 and the T value was 10. So current percent is going to be 82 plus 10, so that's going to be 92. Now, is 92 greater than random percentage? Yes, it is, because the random percentage we assume were 87 and 92 is greater than 87. So this one, the random character that were empty, we're going to get that entry key set. So what was our key set? T. So we're going to get T is equal to random character, and then we're going to break through the loop and we're going to return the random character. So this is how it gets the character with higher probability. Okie dokie, and now let's go through my game. Where is main? Yeah, so that's what we do. We first call the bot and then we do the process game. So let's run that. Let's test our theory. It does the introduction, it does everything, and the bot first gets the E letter. So it does E, then it gets F, then it gets O, okay, and it keeps doing that until it gets the whole phrase changeable from here, and which it had number of tries left at 2, and it won the game. So it's won the game in 5 tries, right? Because we total tries 7. Let's run again. This time it won the game on 4 try. This 4 try. Let's see one more time. Again 3 tries. It's getting better, yeah. This one fight. Oh, I jinxed it. And yeah, that's the working of the bot. It's not the best one, but it's still it wins the game in within 7 tries. So it's not that bad, but it's not that good. It's some in the middle. So yeah, and let me show the chances of each character, and then I can end this. End this. So after doing this, this was the chances of each character from the phrase.txt. So A had 2.89, B has it, da 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 da. E has a lot of chances of this. There's a lot of E in this phrase, and O is also high, and yeah, some letter like Z and X and W, not W, sorry, V. They never get into the phrase.txt, so we don't have those character. And yeah, this is my bot, and yeah, thank you so much, and best of luck with grading the other students. Bye bye.